Hi, welcome to the Oracle Code Online Keynote. My name is Siddharth Agarwal, and I run product management and strategy across our PaaS portfolio. Before we get started, I just wanted to share an interesting story. It seems that people send me to the coldest places, and they sent me to meet some customers in Oslo. And as we were landing, the pilot announces it's -6 degrees and freezing fog has rolled in. We're going to try to land, but if we don't make it, then we have 45 minutes more of fuel. And that made me wonder, well, what happens after those 45 minutes? But anyway, today we're here to talk about blockchain, about serverless functions, and about new application development demands. Serverless is becoming really popular because people want to build applications without needing to pay the whole time for servers being up and running. But that interestingly brings some challenges with it. For example, knowing how to do distributed programming, how to debug across the functions. When you think about chatbots, that's becoming the new interface, a new paradigm in which to engage with your customers. But there, developers have to start thinking about conversational AI, thinking about natural language processing, thinking about state, etc. And DevOps has been wonderful. It has improved our productivity as developers. It has improved the agility of organizations. But today, developers are sometimes spending up to 60% of their time in DevOps. So that means that they're not being able to write code during those 60% of the time. So how do we reduce the amount of time and hopefully head towards no-ops? Blockchain, really exciting technology where use cases are beginning to get into production. But as you think about blockchain, you're now having to think about how to run Hyperledger Fabric, how to make sure that that Hyperledger Fabric runs in a very performant and secure fashion. So you need to get a whole bunch of things going before you can actually experiment with your use cases. And open source, tremendous innovation happening in open source. There's Kubernetes, for example, for container-based orchestration. But in order to get that going, you have to make sure that you can get Kubernetes up and running. They're releasing updates about once every 6 weeks, that you can take those updates, that you can scale Kubernetes, you can put etcd in front of Kubernetes. So how do you consume open source as a service where you as a developer don't have to worry about how to get all of that stuff up and running, and you can just have your containers deployed on a very scalable orchestration platform? And finally, machine learning, tremendous buzz around machine learning. And it gives you the ability to engage with your customers in a very intelligent manner. But the challenge behind machine learning is, how do you embed it into your applications? Or how do you benefit from machine learning without needing to be a data scientist? So those are some of the pros and cons of some exciting technology out there, and how developers are having to think about moving and leveraging these capabilities. And we've built the Oracle Cloud Platform that gives developers the ability to develop and deploy applications really easily, including a CI/CD pipeline. Be able to integrate these applications with back office applications such as SaaS applications or on-prem applications. Be able to publish and engage their customers on content to be able to secure the content. Be able to analyze and predict what is happening in their application in real time, and be able to engage with their customers in real time based on what they want. And finally, security is job number one for everyone. So making sure that you can secure your applications and you spend as little time as possible in managing those applications, where the applications are able to manage themselves, scale themselves, tune themselves, etc. So now let's get to the scenario. I want a scenario to flow through our session today. And here, what we did was, I happened to be walking around the Oracle parking lot. And that's not what I do on a regular basis. But I saw Larry Ellison's Lexus MFA standing in his parking spot. He has a very specific parking spot. And if you guys ever come to the Oracle campus, don't go park there, because there's Oracle security that is watching that particular spot. Well, anyway, it's a very expensive car. And I said, well, let's see if we can sell this car on a blockchain. And someone wanted to make sure there was a nice looking cartoon in this deck. And so here's the scenario that we're going to go through. So we're going to use a chatbot to be able to actually put Larry's Lexus MFA onto a blockchain, using serverless functions to actually be able to put it on the blockchain, and then having a permissioned blockchain where multiple dealers can see the car and someone can buy the car off the blockchain. And so here's the architecture. The chatbots are being built using the mobile cloud capabilities. They're generating events that are going to our Kafka-based cloud service. Those events are then kicking off serverless functions. Those serverless functions are putting the car onto the blockchain network. And this is all about selling the car. And then on the other side, we go through the same process where another dealer, another buyer decide to look up the car, and they're able to see the car on the blockchain and then be able to transfer the car onto their own side. So now let's talk about chatbots. I fly a lot. I fly on United, I fly on Lufthansa, I fly on Virgin. Oracle doesn't pay for me to travel on the same airline, so I can have the best status. And I have a different app for every one of these airlines. And so when I want to check in, I have to check in into Virgin or check in into KLM, etc. So it'd be very easy if I could friend the KLM chatbot. It knows who I am because I'm connecting through Facebook Messenger. It knows that I'm probably looking to check in into the flight in the next 24 hours. It asks me if I'm carrying dangerous goods or not, and I never generally do. And then it generates the boarding pass. And it adds that boarding pass to my Apple Wallet. That's a wonderful experience. And that's the direction where all interactions are heading, which is using chat as the key paradigm of interaction. When I think about my kids, I have two of them, a daughter who's almost 17 and a son who's 13 and a half. They don't communicate with me over voicemail or email. It is just over chat, either Snapchat, Instagram, Facebook Messenger, or iMessage. So chat is overtaking all other forms of communication. And when developers are trying to build chatbot-based applications, there are a few challenges that they come across. They have to integrate with Alexa, they have to integrate with Google Home, they have to think about how to integrate with Facebook Messenger, with WhatsApp, WeChat, etc. Then in addition to integrating with these various platforms, they have to think about natural language processing, they have to think about three-legged authentication with Facebook Messenger, they have to think about back-end integration with those SaaS or on-premise applications, because at the end of the day, the chatbots are going to go to those back-end applications. And finally, they have to become experts on AI. They have to think about machine learning, they have to think about state of the dialogue, they have to think about multilingual natural language processing, understand the sentiment, is a person upset, etc. All that becomes really hard. So before I go in and talk about what we've done to make this easy for developers, let's go to a demo of what this chatbot experience might look like. So now let's take a look at my iPhone here, where I'm going to go to Facebook Messenger. And yes, I have a lot of emails that are unread, and people sometimes ask me what I do at work, if I work at all. But here, I'm going to Facebook Messenger, and this is my Facebook Messenger here. And here, I just go to the chatbot, that is John's car dealership, and I say hi. And hi is just a way for us to wake up the chatbot out here. And it says, welcome Siddharth, are you interested in buying or selling a vehicle today? Well, in this case, I'm going to sell Larry's Lexus MFA. Don't tell him I did that, otherwise I might not have a job, but here we go. So we're selling a car here, and it says, that's great. We offer competitive prices. Can you please upload the license plate for the car so I can do an initial review? Okay, I'm going to go to my photographs, and here's the license plate of the car. So I'm going to send that over. It does some processing out here, and it says, thank you. Can you upload recent pictures of the car? Well, here's the photograph of Larry's MFA in his parking spot. So that is the parking spot. So it says, I want to confirm that this information is correct. It gives me the registration number, the VIN number. Let me take a look at more details out here. And it has information on the make, the model, the address of where it was purchased, the navigation system, etc. Looks pretty correct, looks very high end, so that's good. So I say yes to that. What's the mileage on the car? Well, given that I can only drive 150 miles an hour between 2 a.m. and 4 a.m. on the 280, which runs parallel to our offices out here, I don't drive too much. And so I'll just put in 1,100 miles. So low mileage on the car. And that brings up the Kelley Blue Book value, $375,000. Well, I generally expect these kind of cars to appreciate, but oh well, what's $10,000 out there? So it's saying they'll buy it from me for $385,000. Is this okay for you? So yes, this is fine. And great, we'll continue to process the vehicle and send you the documents for the transfer. So that's an example of the chatbot. It's maintaining state of the conversation. It is calling the Carfax report. It's getting details, etc. So now let's get back to the slides here. And here's what we've done in the conversational AI platform. We built the integration to Alexa, to Google Home, to different types of chat channels. We've also built integrations to Facebook Messenger, WhatsApp, WeChat, and we've given you webhooks. So if you needed to integrate with something else, you could do that too. Plus, we've built natural language processing into it, and it's multilingual natural language processing. So when we get the voice to text from Alexa, we're then able to do processing on it, understand the intent of what the customer is what the customer is saying, get the entities out that that intent needs to act on. And that's all taken care of for the developer. They don't have to worry about it. They just have to tell us a few of the intents. And then finally, we built deep machine learning in it so that you can actually understand sentiment of the conversation. If the conversation is not going well, you can actually hand off the conversation to a live customer service agent if you wanted to. So let's take a look at another demonstration, which is how did I build the bot as a developer. I showed the experience of the bot. So now let's take a look at how I build the bot. So here's a demonstration of how we build the bot. So this is our mobile cloud service, where you can look in here, you can build mobile applications, you can build applications that are visually developed without writing any code that run on mobile. You can build bots, you can get insight into how those mobile applications or bots are being used. So for now, let's just focus in on the bots here. And I'm going to type in car to find all the car dealership bots. And here's the one that we developed, which is the car dealership bot cell. When you come into this interface, you'll first see the intent. This is the intelligence with which we understand what the intent is as the consumer engages with us. And here, you can see that there are different utterances specifying an intent, like here there's buying car, selling car. For buying car, here are the various intents that are there. So now let me try and test this intent here, test the intents. And I'm going to say buying Lexus. Now notice none of these intents here had buying Lexus in it, but it says that buy car with 40% confidence that that is what the consumer wanted to do. So that's great. And you can also see the JSON associated with that. So you can see what the JSON is here. Now if I want to experience as an end user what the bot actually would do, I say buy a car. And there it's now actually acting as if it's the bot that's executing, and it shows me all the cars that are available. In addition to that, we've created predefined entities, for example, address, currency, etc. But you could add an entity, and you could create, for example, an entity that is a dealer, and you can add values to it. For example, name is something that might be an entity out here. In addition, we're doing multilingual processing. And so we're able to show you here that you can add resource bundles if you want it for languages that we might not have taken care of. And you can also add custom components. For example, if you wanted a custom OCR, optical character recognition, on the license plates, you could add that to here. And then finally, we're giving you multiple channels. So here you can see, for example, Facebook is already created as a channel. And if I get rid of this here, you can see that we've got three-legged OAuth. We've integrated with Facebook already, but we're also giving you the ability to have webhooks so that you can integrate with any other channels that you want. So that's a quick demo of how the bot was built. And now if we go back to the slides, you see that this is the platform where we've given you the ability to integrate with multiple channels, to have a dialogue flow managed for you, where we're managing the state of the conversation for you, where we've built a conversational AI engine with natural language processing, with intelligence built into it to understand the intent of the conversation, to be able to parse out the entities upon which the intent needs to act. And finally, giving you a very robust integration platform such that from your chatbot itself, you could integrate with back office applications, which could be either on-prem or SaaS applications, and they don't have to be Oracle SaaS or Oracle on-prem applications. They could be any SaaS or any on-prem applications. And now that we've shown you the chatbot platform, I wanted to introduce Chad Arimura, who runs engineering for our serverless functions platform. Chad, welcome.
Thanks, Siddhartha. So we've been talking about this concept of buying and selling cars across the blockchain, and we've noticed that there's chatbots as the interface into the system. But what's behind those chatbots? If you look at the architecture diagram here, you can see that there's an FN logo, which is a serverless platform to build and deploy custom code as functions. That's what's actually going to be receiving the events from the chatbots and interacting with the blockchain. But let's step back for a minute. What is serverless computing? This is what FN offers. Serverless computing is an abstraction of infrastructure that allows developers to deploy functions to the cloud and not have to worry about provisioning, scaling, and patching. At the end of the day, they're building software without ever thinking about the infrastructure underneath that's required to power those functions. Functions as a service is the compute component of a serverless architecture. You can have multiple components to your serverless architecture, including compute, storage, and networking. Functions as a service is the platform that takes care of the computing aspect of that serverless architecture. But why should you care about a serverless architecture? Well, there are a number of great benefits to this architecture. For starters, you can seriously reduce your cost by only paying for the time your particular functions execute, oftentimes to the 100 millisecond increment. This is much different than the traditional model where you can stand up a server and you're paying for that thing indefinitely. You're also much more agile as a developer shop because the code is much smaller and there are many less dependencies. So you can ship these things to the cloud hundreds, even thousands of times per day using a CI/CD system. And it's much more reliable out of the box because your critical apps are going to be running on a management platform that somebody else is operating for you, and the system takes care of a lot of those tasks. And of course, you can innovate faster because you're more agile, you've reduced your cost, and you can actually try new things out much quicker by getting code to the cloud and be much more efficient with it. With that, I'd like to introduce the FN project. The FN project is an open source serverless computing platform that allows developers to build and scale these functions in the cloud. But the FN project can be deployed to any cloud, even on-premise, allowing developers to easily build and deploy these functions to any cloud, including their private cloud as well. It's simple, elegant, and extensible by design. Containers are the primitive, meaning anything that you can containerize into a Docker container can become your function. The project is very active today with over 2,500 commits across 50 contributors, both internal and external to Oracle. And today it's being independently governed with representation in the CNCF working group. Eventually will be put into a foundation. So what is an FN function? An FN function is really just a small bit of code wrapped inside of a container. It gets its input on the standard interface, and then it produces some output to both standard out and standard air. It's a very elegant environment and a very developer-friendly experience. The FN server takes care of everything else, including piping around all of the functions. It provides an API gateway out of the box and also stores your calls and your logs for later viewing. The developer experience really boils down to 5 commands: init, run, test, deploy, and call. Again, FN init will give us an easy runtime, just some boilerplate code to get started. FN run will build that container and run it locally. FN test will build that container, run it locally, but pass in some pre-built inputs and ensure that you get some output. And the beauty of that is that you don't even need to know what's inside the container to be able to run your tests. Deploy now takes that same container, deploys it to a registry of your choice, and then registers that with the service that you have active. So that's essentially deploying your function to the cloud. And then FN call runs a curl command against that function to be able to run it on the remote server. And a common theme you'll see amongst all of these, which I'll show a demo in a minute, is that they all build a container in the same way so that you know you're getting the same deployment artifact every single time. Consistency is king here. So with that, I'd like to show a demo of how FN works. So as you can see from my terminal here, I have an empty directory. I'm going to start with nothing. I'm going to simply run fn init -- runtime go. And what this does is create some boilerplate, a function in Go. So I can say I have a go package.toml, func.go, func.yaml, and test.json. I can start up by easily typing fn run, and now it's building the Docker container with the function that I developed from my boilerplate, and I get back the message hello world. Of course, this is expected. I can even run fn test because this is the boilerplate that we get out of the box from fn init. And you can see that we have 2 tests that pass. Let's take a peek into what our func.go looks like. It's a very simple function written in Go that takes its input on standard in and then returns hello world, or if I get an input, I return hello, whatever that input is. So I can do something like name. So let's give it some JSON. Oracle Code Online Audience. And then let's see, does that look like JSON? I believe it does. Now I can actually take this and pipe it directly into FN run using standard Unix piping. And now I get the response message, hello, Oracle Code Online audience. That's because it took its input on standard in and produces some standard out. And so now, when I did FN test, it's taking, what was that file? It's taking test.json, passing into inputs, and I get an output ensuring that everything is working properly. So one other thing is now we're going to take this and we're going to deploy it to app demo. Same container building process, but this time I'm actually giving it a FN bump, which is happening behind the scenes. Now we get an artifact 0.0.2, pushes it to the registry, and I can do FN call demo hello, and I get back message hello world. I can even go into a browser, and I can go API FN service our demo hello, and I get the same output from my browser. Pretty cool. So now I know we've been talking about Docker. We can use Docker containers as the native function. So let's go in and change our func.yaml. Let's change the runtime to Docker. And then I get rid of the format. I don't need an entry point. And let's create a Docker file. If you're familiar with Docker, this is basically just the most standard Hello World Docker example we can use. And now when I type fn run, I see the standard boilerplate text from the container that's hosted on Docker Hub, which is just the standard Docker image. We did nothing to modify it or customize it. It just works out of the box. And anything that can go inside this particular, any container can be your function. So that's pretty cool. But we don't just operate in a vacuum. We actually need multiple functions that can talk to each other. That's where FN Flow comes in. FN Flow is a system to orchestrate, build higher level orchestrations and workflows out of multiple functions. And what we did was we took it a step further, and instead of describing these workflows in long JSON, which we believe should really only be read by machines, not humans, we're actually taking familiar code out of APIs. For example, with Java, we took the completable future API, and we've done similar things with Node and Go as well. And you can now string together your workflows using and reasoning just like a normal Java application. The beauty about this is it actually takes all of your variables, reconstitute those throughout the entire stack, and gives you the hard things like variable reconstitution and memory allocation and concurrency and parallelism. So these are really cool things that you get from FN Flow. In the example of the blockchain, if we have a single function, call it a sell car function, things are pretty easy. We've got one function, and that talks from the Chatbot service, and it posts to the blockchain. But now what happens when your manager comes in and says, we're not just selling the car, we're actually running a whole bunch of other stuff. This other stuff includes things like Carfax reports, criminal history lookups, could be FBI lookup on this car to make sure that the car is kosher before it gets sold on the blockchain. It's much harder now to go in and build all this stuff and force it in. That's a monolithic model. What we've done with FN Flow is you can create each of these functions, and instead of tying them together using coupled REST calls, we remove those REST calls into familiar completable future code, and we pull that out into what we call a flow function. And the flow function runs independently, and that decouples all of our functions, so now we can iterate on each of these individually, but they all roll up into that flow, which gives us that nice higher level orchestration and workflows. We're going to breeze through this pretty quickly, but if you look at just a really quick code example of what FN Flow looks like, you get things like completable futures. We create the flow future. We go ahead and we create a flow future here, and then we do an all of, and then a then apply. These are very familiar syntax if you're familiar with Java 8 futures. And then at the end, we can do a number of invoke functions, which is a helper call to invoke more functions. And at the end, we do a when complete. So we ensure that when everything is finished, we can get the result back, knowing what the state of all of the different calls were, and failing if any particular step in the chain failed. So this looks and reasons just like a single Java program. You can test it just like a Java program, but in fact, there's a whole bunch of functions. In fact, thousands could be actually executing in the background. So to show you a quick demo of that, I'll turn back to our terminal here. And now we've got a flow function. If I can actually do fn call code flow. What this is a wrapper around curl, and I'm actually triggering the function in the cloud. And this is our experimental UI around our flow function, and it's a graphical representation of a workflow running in the background. So we've got our get cars. We're processing each car. We're now fanning out to both the Carfax and the criminal lookup. And so there are actually multiple functions in here running. The coolest thing about this, though, is I can click on any particular node, and I can actually view the call stack, including the logs of every function all the way down the call stack. So I can see here that I pulled up the criminal history for this Tesla Model 3, plate number 2NOGA55, and I'm composing it from a processed car. Here's the log here. I'm composing that from the get cars, which actually hit our API, which pulled multiple cars. And you can see here I've actually fanned it out, so I can click on any of these and I can see all the logs there. So this is really an incredible way for developers to be able to consume and build very much more complex applications, but be able to reason about them just like a single Java application. So it's a very great debugging tool for developers. And yes, we will have a service called Oracle Functions coming later this year based on upstream FN. It'll have all the familiar APIs that you get from the open source FN project, but now as a managed service and optimized for the Oracle Cloud Infrastructure. And of course, Oracle cares deeply about security. We'll be integrated with other Oracle security solutions for end-to-end protection so that you can ensure your code and your customers are safe. Finally, we have integration with our Oracle API platform. This is the perfect pairing because it allows developers to easily build, test, and deploy prototype APIs, and then be able to test those on a mock server and deploy it before they deploy it to production. And then after it's in production, they get the end-to-end security from the API platform, and they get full visibility and insight into that along with the platform. Well, this is the perfect pairing because you can now build and test and deploy an API to the cloud, but you can actually back each of those endpoints using an FN function. And you can iterate on each of those endpoints individually so you can move much more quicker in your enterprise and you can innovate faster.
Chad, that's wonderful. I mean, you and your team have done an amazing job of building this open source project. And with open source projects, we want to have as much of the community participating as possible. So how can the folks on this Oracle Code Online get engaged with the FN project?
Well, I actually have a bullet for that. You can try FN today. You can even contribute to the project by starting at fnproject.io. It will lead you to all the great resources we have, including our GitHub repository, where all of our code is open today and online.
Well, thanks a lot, Chad. That was a wonderful presentation, especially demo. Really loved it. Thank you for being here.
Really appreciate it, sir. Thanks for having me.
Thanks. With that, I'd love to move to the next part of our demo scenario, which is about how the car enters the blockchain and how transactions can be done on the blockchain to buy and sell the car. For that, I'd like to welcome Jagdeep Singh, who runs product management for our cloud platform. Welcome, Jagdeep.
Thank you, Siddharth. It's really a pleasure to be here. Everybody has heard about Bitcoins. What I'm going to talk about is how all the money that you made using trading Bitcoins, how you can use that to buy the car that Siddharth just sold. That LFA, the Lexus that Larry owned, Siddharth got a hold of it, was able to sell it. We are going to buy it here. Let me show you how you can do that using chatbots. There are about 2 billion people in this world, right, who are using Messenger. My daughter, who's 15, the only way I can talk to her is using Messenger or chatbots. So let me show you a demo of how we are going to buy a car. We friended this bot from a Bob's car dealership. This is the car lot that we have right next door to my house. Here are two options. Siddharth sold the car. I'm going to buy a car here. All right. He has a nice inventory here. He has an Audi, he has a Cadillac, he has a BMW. These are not the cars I'm looking for. What I'm looking for is a Lexus. So let me see if he has a Lexus. Awesome. So what he's saying is he does not have a Lexus on his lot, but he's part of a network which has a Lexus. So this car looks good. Let me look at some details here. By the way, this looks like Larry's car. Wow, 1,100 miles. A dollar short of $400,000. A lot of dough. Hopefully I made that using that Bitcoin trade I was talking about. I like what I see. I'm going to buy this car, and let's see what he says. So it has been transferred over from Jones dealership to Bob's dealership, and I'm just going to confirm it here. It's asking me what time I can come and do a test drive. Say 2 p.m. tomorrow. Awesome. So we are all set to be there tomorrow at 2 p.m. to pick the car up. All right, so we just transferred the car. Let me walk you through of what really happened here, right? Using chatbots, we were able to place the car on the blockchain, and using chatbot again, we were able to buy the car from the blockchain, right? So this car went from Jones dealership to Bob's dealership, and finally we are going to pick it up tomorrow. So with that, let me walk you through what is really blockchain. A simple definition of what blockchain is. It's a decentralized and distributed digital ledger used to record business transactions permanently across many different computers in such a way that they cannot be changed retroactively. These transactions are based on consensus among multiple parties that don't necessarily trust each other. The power of blockchain is that there is no intermediary required. Decentralization and collaboration are powerful attributes. This is how business is done in the real world as well. However, there is more to the story than distributed ledger. Most of you know about Bitcoin. Bitcoin is an implementation of blockchain. But in the Bitcoin model, it's a permissionless model, and it's a shared consensus model. Anybody can join it. I have made enough to purchase this car, for example, in this scenario, right? But in the enterprise, we see a lot of use cases for blockchain. Here's a sample list of all the use cases that we see. I'll walk you through a couple of these. Think of an industry like airplanes. Think of working for Boeing. Every part that goes on that airplane, we need to know where it came from, what its service history is, right? That's a perfect use case for blockchain. I bought a $400,000 car. I want to make sure that every part that went onto that car is a genuine part. The services on that car were done at the right time, right? That's a perfect use case for blockchain. Think of an industry like shipping industry. You're shipping all these goods across the ocean. There's so many parties involved. There's a shipper, there's a receiver, there are a lot of government agencies involved. All that paperwork can be taken care of using blockchain. Think of simple things like background checks. Everybody has about 27 different identities, digital identities, and yet they have no control over their identities. A simple leak, like Equifax, for example, all your identities are leaked all over the map. There is a lot of effort that goes in at this point to use blockchain for all these identity systems. So what can blockchain be used for? You saw all these use cases. Can it solve world hunger? Probably not. So how do you figure out where to use blockchain? Think of transactions where there is an intermediary involved, which is causing a lot of friction, right, in the transaction. That's a good use case for blockchain. Think of transactions that need reconciliation over time. Think transactions that are going over many different enterprise boundaries. That's a good case for blockchain. Things that you need to keep an audit trail for. Things that you need to figure out in real time, where are you on a transaction. That's a good use for blockchain. So we went through a couple of these examples here. And how is it different in an enterprise versus the Bitcoin example that we talked about? Enterprises need confidentiality, and enterprises need security of transactions, right? Those are the key things that are missing in a Bitcoin implementation. What I paid the dealer, I know about that. But what that dealer paid the other dealer, I don't need to know about that. The $25,000, $30,000 benefit that he got out of that transaction, I don't need to know that. I don't need to know what that part was bought for. We talked about all these things, but yet we don't see a lot of adoption of blockchain yet, early stages in the industry. Why is that? Right? There are a lot of challenges that happen in using this blockchain. I'll walk you through a couple of them. Every company has existing systems and new systems. How do you match and plug and play these things? How do the integrations happen? The implementations of blockchain that you're seeing right now are not production ready. Every enterprise needs some basic characteristics. They need scalability, they need security, they need resiliency. Those things are missing as far as the early implementations are concerned. There's a lot of technology churn. Things are changing rapidly. How do you make sure as an enterprise that your investments are secure and there is backward compatibility? Operational challenges, especially in blockchain implementations, because this is spread over multiple companies, multiple organizations. Who takes care of patching? Who takes care of backing it up? Who takes care of recoverability? All these challenges need to be addressed, right? So introducing the Oracle blockchain service. What we have tried to do here is a pre-assembled managed service, if you will, where everything is taken care of by us. It's based on a robust infrastructure and PaaS layer. And on top of it, all the integrations are already pre-assembled and pre-taken care of by us. The blue box in the middle that you see is a hardened implementation of Hyperledger Fabric. Why did we use Hyperledger Fabric and not other open source platforms? One is our commitment to open source, and second is it's a very modular architecture. It's very programmable, and it lends itself to a permissioned blockchain implementation. That's why we are using Hyperledger Fabric. So you just click once and you are ready to go. Let me show you by a quick demo here of how we did all this. How were we able to transfer the cars, and also what the blockchain scenario looks like. There's an application that's built on top of blockchain here. What I'm going to do is first go and look for that car. So if you remember, 6LIK274 was the license plate. I just looked at it. On the right, what you see here is the API implementations. Everything that we do in this service is exposed as an API, which is callable here. So if you look at this, so here the car was transferred from one dealer to another, and here's a record of that. So moving along, this is a dashboard built on top of that Hyperledger. What you see here is how many transactions were done today. Let's look at what was done in this last month. There were 44 successful implementations. So let me show you what the network looks like. So Detroit Auto is the founder member, and then you have these other dealerships that have joined the network. Jones dealership, Bob's dealership, Tim's dealership, they have all joined this network. What does that network look like, right? The blue dots that you see here are the organizations. The green dots that you see are the remote computers where the ledger is stored or the transactions are committed to. Then you have an order service and a service which is basically validating people that are coming on. Moving along, what you see here are the nodes that are running in this blockchain service. So a particular node that I wanted to point out is the REST proxy node. Everything that you are doing in this service can be called as a REST proxy, right? So this is a key thing here. Another thing that we were talking about, the benefits of a permission chain. So what you see here is a bunch of channels. This is the dealer channel. Whatever is written on this channel, all the dealers are part of. So there is a ledger that is going along with this channel. All these dealers can read off of this channel. And yet, Jones dealership here can have a private channel with Detroit Auto. So anything that's written on this particular channel, nobody else can read. So it gives you the privacy, the security, the confidentiality that you need from an enterprise perspective. Here are the different channels. Let me pick one particular channel. Say, let's pick Bob's channel. These are the blocks that have been committed to this particular channel. Then introducing the concept of chain codes. These are smart contracts. These are the business contracts. The business logic is implemented using this. How do you implement a chain code? I'll show you the code behind it, but you pick up the nodes that you want to install the code against, and you just say install the chain code. You upload the chain code file, define the peers, and off you go. Once you have installed the chain code, then you can do an instantiation of the chain code. So one key thing that I wanted to point out here is the endorsement policies. What I can do is I can add how many organizations need to endorse this transaction before this transaction can be put on the block or committed to the block. Once I do that, I can instantiate that chain code, and off we go. We're done from what a developer needs to do to make that transaction workable here. Let me walk you through what the actual chain code looks like, right? So here, all this code is written in a Go, right? That's the language that we are using. So if you look at this code, you basically are defining the structure of the car, and every operation that you do with this ledger can be done through this. So we were transferring the cars. There is a block of code here that we basically implement all the transfer aspects of it. Once you have done that, once you have written the code, you just install the code, instantiate the code, and there's nothing else that the developer has to do. What you saw is how easy it is to get a system up and running. From a developer perspective, there are basically three things that he's doing. He wrote the chain code. The pink boxes that you see here are where he installs that software. Then he builds applications on top of it using the REST APIs and the SDK that we perform. And on top, what you see is how he's going to configure the system. He configures the system, and everything else is taken care of. So I just showed you how you can build applications on top of blockchain. All a developer needs to do is write some code, use the REST APIs, do some configuration. He does not have to worry about any management of the service itself, any integration. All the pain points that we talked about are all taken care of. With that, I'll hand it over back to Siddharth to do some finishing comments here. And you just saw how you can do this very seamlessly.
Well, thanks a lot, Jagdeep. That was wonderful. It did make it look like it was very easy to implement a use case on top of the blockchain cloud capabilities that Oracle provides. So with that, I just wanted to summarize the application development platform for Oracle. We're providing you an entire CI/CD pipeline where you can have continuous integration built in, or you can bring in Jenkins if you want with webhooks that we provide for Jenkins. Plus, the CI/CD pipeline knows about containers. So when you check in your code, it automatically knows to build a Docker image. It knows where to register the container into a registry. It could be a public registry or a private registry. Plus, you can build cloud-native applications because we're providing managed Kubernetes as a service. So you can just deploy your containers onto this Kubernetes platform. We'll take care of scaling it, securing it, making sure it's highly available. And we spent a lot of time on the Chatbot platform, so being able to easily build mobile applications or chatbots. And then the API pieces, where we're providing Apiary, and you can go to apiary.io, and you can design your API, and we give you a mock server against which you can test the API without writing the implementation of the API. Plus, there's a full-fledged API gateway and API management platform for being able to design your governance policies, et cetera, associated with APIs. And this API gateway can run either on our public cloud within your data center or in a third-party cloud. And if you're WebLogic customers, if you're using WebLogic, we obviously give you WebLogic available as a service. And finally, the ability to build applications visually without needing to write code. So with a drag and drop, you as a developer could build a rapid prototype and show it to your line of business users to see if that is what they wanted. Or the line of business users can easily build their version of an application and give it to you as the developer to implement, so they can visually agree on what that platform or what that application should be. And this is what our overall platform looks like. I've talked a lot about the front-end tooling and the back-end services around application containers and functions. A couple more things to point out here. We talked about open source as a service. So we're providing Event Hub as a service available to you. So instead of you needing to set up Kafka, to scale Kafka, to configure Kafka, we're providing that as a service. So as message storms come in, we scale up the Kafka service, and we bring it down so that you're only paying for what you're actually using. Similarly, the Container Cloud is our managed Kubernetes capabilities. And then we're also providing identity as a service. So you can easily have single sign-on. You can easily have identity management integrated into your application. And just because we're Oracle, we don't want you to think of Oracle databases the only kind of databases against which you can program. Yes, we provide Oracle databases as a service, where the scaling, the monitoring, the patch up, the backup, the patching, the backup recovery is all taken care of by Oracle. But we provide that same experience with MySQL delivered as a service, or Cassandra, which is a NoSQL store delivered as a service. Or if you want, you can run MongoDB on our IaaS. And if you wanted Hadoop clusters, we also give you Hadoop available as a service. And finally, for integration, we talked a lot about integration and how important integration is. So we've made it very easy to be able to build integrations from your applications to back office applications with just drag and drop, not needing to write any WSDL, not needing to open up an IDE, but very easily be able to build integrations. And all of that running on our cloud infrastructure. And you have that available either in our public cloud or within your data center, because we give you the ability to consume our public cloud within your data center, delivered as a service, consumed as a subscription. You pay for as a subscription even within your data center. And just from a momentum perspective, lots of customers, 14,000 plus customers, lots of apps already deployed in our cloud marketplace. And also the analysts, we're in the Gartner quadrants, in the Forrester Waves, et cetera, as leaders in many different analyst research that's out there. And then for developers, we're providing a central location for them to be able to go and get access to resources that Oracle provides for developers. That's called developer.oracle.com. Engage with the community on developer.oracle.com. Plus, this is the Oracle Code Online event, but there are also Oracle Code local events that are coming to you. We've already done a number of them in North America and in Europe, and they're also coming to Asia Pacific. So you can go to developer.oracle.com/code to register for these in-person events where you can have a lot of hands-on experience. You can build applications of your own hands-on at these various events. And lastly, I welcome you to try the Oracle Cloud. We're providing developers $300 in free credit. And this is even if you're using the PaaS capabilities, it is just measured at the IaaS rate. So you have a lot of time to be able to experiment with your cloud credits. It maps to about 5,700 hours. And you can go to cloud.oracle.com/try. So thanks a lot for listening to us. Thanks a lot for participating in this Oracle Code Online event. We'd love to take questions. You can type in questions into the online forum. Thank you.